It is one of the greatest tragedies of modern times. A quake so powerful, it knocks the Earth off its axis. A tsunami leaves tens of thousands feared dead. Parts of Japan shift 10 feet out to sea. Parts of the coast drop over 3 feet. What forces create this epic disaster? Now a team of scientists is looking for answers.
Never before have we had such a surplus of data. There are no mysteries in this earthquake. We know exactly what happened.
Japan's coast lies in ruins. Incredibly, it could have been worse. Scientists' understanding of earthquakes and tsunamis saved lives. But as this disaster shows, there is much more to learn. Japan's killer quake, right now on Nova. It is 96 hours since Japan's largest earthquake in 1,000 years strikes. Professor Roger Billum from the University of Colorado is one of the first geologists to survey the aftermath.
So we're flying right over the coast right now, and much of the coast has sunk about a meter. The extent of the damage is truly amazing. The tsunami picked up everything in its path, cars, houses, warehouses, and just tumbled them relentlessly inland, on and on and on. One of the things I'd like to see is exactly how far it went, what kind of debris gets left behind on these gigantic tsunamis.
Every detail of the disaster is recorded by seismometers, strain gauges, and tidal gauges. Now Billum looks to piece it all together to find out exactly what happened and why so many lives have changed forever.
70近いのね。なんとか今探したいと思ってきました。
How did this happen? March 11th, 2011, 2:46 p.m. Japanese time. 60 miles off the northeast coast, a massive earthquake. Seismic waves race toward shore. The fastest waves, called P waves, travel at 4 miles a second. 15 seconds later, they hit land. Japan's detection systems instantly pick them up. Within seconds, automatic warnings flash across the country. A computer-generated announcement interrupts a Japanese parliament broadcast. The coastal city of Sendai lies just 80 miles from the epicenter. There's almost no warning before slower, more destructive seismic waves called S waves hit the town. These slower S waves violently shake the ground from side to side. These are the waves that make earthquakes so damaging. Already, northeast Japan is descending into chaos. The seismic waves travel on. 93 miles southwest of the epicenter, they slam into Fukushima Daiichi. home to an aging nuclear power station housing 6 reactors. This video from a hospital near the reactor reveals the earthquake's power. Sensors at the plant automatically shut down the reactor cores. The reactors are in lockdown when the S waves hit. But the intense heat generated from the nuclear reaction process does not simply dissipate.
When you think shutdown, you think, the danger's gone because it's shut down. But the reactor core was still extremely hot. If you have a pan in the oven and you shut the oven off, that oven continues to heat inside even after you've turned it off.
With the reactors stopped, there's no power to drive the cooling pumps. The reactor cores heat up. Emergency diesel generators take over, pumping coolant through the reactor. The Fukushima plant survives the earthquake intact. Scientists 3,800 miles away at the Pacific Tsunami Warning Center in Hawaii receive emergency alerts. Researchers around the world see the event unfold.
Japan has lots of seismometers, so there was a lot of information fast. So the earthquake was still going on when we got our page.
First indications, a magnitude of around 7. But as data floods in, the numbers start to climb. 7.5, 7.7, up into the 8s.
The immediate reaction of everybody was, that's not right. Because in the history of Japan, there has never been an earthquake larger than 8.4.
Really heightened the intensity of what we were doing, because we knew we were dealing with something very big and something that could affect the whole Pacific Basin.
We realized, oh, this is it. And then immediately you realize, this is horrible for Japan.
The source of this disaster lies 62 miles off Japan's coast. 4 miles below the surface, the Earth is distorting, caught in a vast slow-motion collision. The Earth's crust is made up of several continent-sized slabs of rock, tectonic plates. Japan lies at the point where the Pacific plate rams into the Eurasian plate at 3 inches a year, about the same speed your fingernails grow. Japan is on the Eurasian plate. It compresses and buckles as the Pacific plate drives underneath it, snagging and catching as it goes. Over centuries, immense stress builds up until suddenly the plates snap, causing an earthquake.
The energy that drove this earthquake had been building up for a couple of hundred years. It's caused by the movement of the Pacific plate towards the Eurasian plate. Think of it as a giant elastic band that's being wound up for 200 years.
100 seconds since the fault line slipped, the destructive S waves reached Tokyo.
Tokyo 渋谷のスタジオが非常に大きく揺れています。東京の渋谷のスタジオが大きく揺れています。
The city has 60 seconds warning. The quake lasts an unprecedented 5 minutes. An American geologist is in Tokyo.
We expected it to end after 10, 15, 20 seconds, something like that, maybe a minute at the most. About minute 3 or 4, we were just all kind of astonished that it just kept going and going and going. Just looking at each other going, is this over yet? And no, it's not, it's still going.
What is different about a big earthquake is that it begins, but it doesn't stop.
It was kind of a growing realization that it was just getting bigger and bigger and bigger, and it had to be fairly close.
An American tourist captures the ground opening up at his feet. The footage reveals a frequent characteristic of earthquakes: liquefaction.
Okay, we have earthquake right now, and this is actually moving. Can you see the cracks moving? That crack was not there. That crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now.
Loosely packed and waterlogged ground near the surface starts to behave like a liquid. As the ground compresses, liquefied dirt pumps to the surface. Most buildings still stand. Japan's earthquake warning systems work. Scientists upgrade this quake to a magnitude 9, 1,000 times more powerful than the devastating 2010 Haiti earthquake. But everyone in Japan knows this is far from over. The earthquake's explosive energy is about to unleash another destructive force. For centuries, the Eurasian plate is dragged downward by the Pacific plate grinding under it.
The whole upper plate behaves just basically like a rubber block. It just compresses, and like a spring like this. And when the earthquake happens, it springs back.
The upward motion thrusts a 4-mile-deep mass of water upwards. When the dome collapses back, immense waves race out across the ocean. Just 3 feet high and over 60 miles from front to back, the waves travel at a blistering speed. A tsunami is born.
The energy heaved up the sea floor. That displaced vast amount of water that we can see made it its way on land, it made its way off around the Pacific.
One side of the wave takes off across the Pacific. The other races towards the coast of Japan.
Tsunamis travel very fast at a speed that depends on the water depth. And because in the deep ocean, tsunami travels very fast, reaching at times the speed of a jet aircraft.
Traveling at over 500 miles per hour, the wave takes just minutes to reach the coast. Here, the shallower seafloor slows down the front of the wave. The wave's fast-moving rear races in. It soon catches up with the front. The increasing pressure pushes the seawater up into a rising swell. 3 miles from shore, a Japanese Coast Guard crew witnesses the growing wave. The tsunami swells up as the seafloor gets shallower. Once they crest the first wave, a second one is upon them. The crew is lucky to survive. Near the coast, the swell becomes a breaking wave. it piles up. A wall of water races toward shore.
The very first thing that seems to have happened is that the sea left the land, and some of the footage we've seen shows a huge shoreline being exposed. And then the tsunami built up offshore, and the dynamics of the wave carried it inland. Probably a cubic kilometer of water just splashed landward and kept going until it ran out of steam.
This is the moment the first wave roars in. The tsunami has arrived. But there appears to be no clear pattern to when or where the tsunami strikes. First, it hits in the north. Then in the south. Then it strikes in the north again. The height and intensity of the wave varies dramatically from town to town. But why? Part of the answer lies in the varying depths of the seabed. The tsunami travels faster in deep water and reaches land more quickly. Another critical factor is the layout of the land. Cliffs, bays, and inlets along the shoreline help determine how a tsunami behaves.
It boils down to how the wave is focused and defocused by the geography or the topography of the coastline itself.
3:15 p.m. Japan time. The wave hits the town of Okhotsk. Deep water off the coast here offers little resistance to the 26-foot-high tsunami wave. There is little time to get to high ground.
The best early warning system people would have had would have been the fact that there was an earthquake. And people have got used to the fact that if you have an earthquake, there is a possibility of a tsunami that will follow. But in the timescale they had, there was very little time or very little opportunity for escape.
The tsunami hits Okhotsk 20 minutes after the earthquake.
Water that actually hit the coast will be well in excess of 1 billion, probably 10 billion tons of water. That's a little bit like taking 1 million swimming pools and just emptying them onto the coastal areas of northeast Japan.
"15 minutes later, the tsunami hits Sendai, 70 miles south of Okhotsk. The area around the city is mostly farmland, low-lying and flat. The airport here is overwhelmed in minutes.
It hits very low-lying areas. There's nothing to stop it moving inland, and so it can move inland 6-7 kilometers without being impeded.
There's not much to slow it down, and because the wavelength of the tsunami is so big, it's not going to stop until it reaches something, reaches some sort of high ground, and it'll just keep on coming.
Next, the wave slams the Miyako coast, 110 miles north of Sendai. This area has good tsunami defenses. The residents are well prepared. They should be safe. Last time a tsunami hit here was half a century ago. In the aftermath of that tsunami, they built these 30-foot-high seawalls. Tsunami drills are a regular feature of life. Everyone knows what to do when the sirens sound.
Tsunami, yeah, we're leaving. Where do we go? Go to the hill.
On March 11th, the sirens sound. The tsunami is minutes away.
You hear the sirens?
There's a hill outside of town that we're going to try to get to.
Confusion rules. Some search for high ground. Some aren't sure what to do.
Well, it's a precautionary measure, but I mean, you never know. This town has a lot of history with tsunamis and a lot of death from it, so they're taking it pretty seriously, obviously.
The warning saves the lives of some.
Here it comes!
The tsunami easily breaches the coastal defenses. Miyako's high walls are useless. The tsunami is 30 feet high. So why did the 30-foot-high walls fail? Data from thousands of sensors along the coastline suggest a stunning answer.
The fact that the shoreline has actually subsided means that the sea had plenty of space to go, and it basically filled up the empty space left by the sinking. Several villages have just been completely ruined with no survivors, and the human death toll is obviously going to be up in the tens of thousands when the final count is in.
The earthquake causes the whole coastline to drop by up to 3 feet, lowering Miyako's walls and making the tsunami much worse. All along the coast, this sudden drop in the height of the land puts towns in danger.
You've got the tsunami wave coming in, on top of what would be essentially a 2-meter higher vacuum of subsided land as it sweeps in, and there's not much to stop it until it hits higher ground somewhere.
Fukushima's shut-down nuclear power plant is exposed. There is an 18-foot-high defense wall, but the ground has sunk several feet. The wave smashes over the wall and floods the diesel generators cooling the reactor cores.
Japan, as part of its normal defenses against tsunamis, has along its shoreline a tsunami wall, and this wave of water was several times that height and just blew right past it.
The coastline goes down, so do all their power intakes, and if they have a gigantic wave coming at them, it's going to short out everything electrical.
Backup batteries take over to keep the pumps going. Batteries with just an 8-hour charge. The tsunami's destructive march inland overwhelms seawalls. erases whole towns and sets Japan on the path to a nuclear crisis. And it isn't over yet. Now, all that water pulls back out to sea.
Huge suction as the wave retreats and drags the debris it's created on the way in, the cars, the lorries, the buses, the trains, the buildings, the people. And so they're sucked back out into the ocean.
From miles offshore, the ocean is a churning mass of currents. Huge whirlpools form. Boats like this are no match for its power.
Sadly, I think many thousands of people would have been dragged out to sea. And I suspect, tragically, we're going to find bodies washing up along the coast of Japan for some months to come.
During the night, fires rage across the wasteland. Oil from factories and natural gas from ruptured lines set hundreds of square miles of debris on fire. In Tokyo, the train system is paralyzed. Millions sleep in offices and wait for dawn. 8 hours after the quake, the tsunami wave continues to spread across the ocean. Countries all around the Pacific Rim watch nervously. In Hawaii, the Tsunami Warning Center is on full alert.
Very quickly, we realized that this was basically the first big ocean-crossing tsunami that had happened in 40 years.
Will the tsunami hit Hawaii? If so, when? And how big will it be? Readings from deep ocean sensors suggest the wave is up to 3 feet high.
Now that is monstrous on the deep ocean for a tsunami to be that big. And at that point we went to a Pacific-wide warning, which means another message, and now lots and lots of phone calls.
State warning point. This is the Pacific Tsunami Warning Center.
Hawaii issues an evacuation alert. People head for higher ground. The wave hits Hawaii. As predicted, it's 3 feet high. For more than an hour, it surges over the islands.
Whoa! Gosh, that is big. That is absolutely massive. Just lost my shoes. They